Hi, so this is Mohammed from PYCAD. I think most of you have already heard about nnUNet model for medical image segmentation because it is like the state-of-the-art model and it is used by a lot of researchers, let's say. In the production, it is still not the one used all the time because most of the productions are building their own models. But for the research purpose and some of the production, let's say some of the companies, they are using the nnUNet for their models. And yeah, for this video, I wanted to show you how you can train your model to do image segmentation. So our task will be the spine segmentation, so we will segment the vertebra. And yeah, but the only thing that you need to know about nnUNet that it requires a high computational resources for the training and for the inference, especially for the training if you have a large data set. But yeah, in this video I will show you how you can allocate a server to do that. For sure the server will be paid, it won't be for free. But if you do already have your own server that can be used to train an nnUNet model, then you don't need to worry about that. The same steps will be used for your local server or another server. But yeah, we will do that. And I think also you can do the same process in Google Colab if you don't have a large data set, because I think 12 GB will be enough to train a small model. But yeah, let's do that. And in this video, you'll see the steps that will be required to do the training and to do the inference. And at the end of the video, I will show you how you can use your model after that. So it will be just small demos where you can deploy your model to do to create small applications, desktop or web applications that uses your model for users, like especially for MVPs. And yeah, so let's dive into the video and see what we can do with nnUNet. So before that we start coding or talking about the code, because most of the part that we will discuss here are already written code. So for the part of nnUNet, we don't even need to write code. We just need to run the script, the commands from nnUNet. But before that, we just to prepare the datasets, we require some coding. But I have already created that, so I will just show you how you can use it, and then you will see that the steps are very easy. So we will use a notebook on the server that we will allocate. But before that, I just wanted to show you the different steps that we have. So this is my draft, and I will, let's say this is my white sheet, and then I will share it with you if you want. And it contains all the steps that we will do for this course. So the first thing that we will do, we'll create a folder of the dataset, we'll download the dataset, we will unzip the dataset. Then for like nnUNet requires a specific structure of folders. I don't know why they do this, but I think they built it for themselves, so it will be easier for them to treat their datasets. We need to respect that. We just need to create our folders in the same structure so that nnUNet works. Otherwise, if you want to change the structure of nnUNet itself so that it doesn't need these, then of course you have already the possibility to do that. The code is open source and you can modify it as you want. But to follow the course and to have it easier for you and for me and for everyone, we will try to just stay organized as nnUNet is waiting for the folders and for the commands and everything like that, and also for the dataset naming. We'll come to that later, but just to show you here. So as I said, we need to create the folders. So they will require 3 folders: the nnUNet row, the nnUNet preprocessed, and the nnUNet results. So the nnUNet row is the folder that will store the input data sets that we have, but after renaming, because your data set that you have already in your PC or the data set that I will share with you for this course, it is not the correct structure or the correct format for the nnUNet. So whenever we do the correction or whenever we create the exact format weighted by nnUNet, we put it here in the nnUNet row. Then whenever we do the pre-process, because nnUNet, they have pre-process function, we run it by command directly. We don't go directly, we don't go to the code and see what is happening. But if you do want, you can also do that. And whenever we run the command for the pre-process, the dataset that will be pre-processed will come from the row into the pre-process. So in the folder pre-process, we will find the dataset that will be used for the training directly after pre-process. And then the folder nnunet results will contain all the results of the training, inference, evaluation, whatever you run using the nnunet commands. So everything will be stored here. So the model weights, the logs of the whole training, whatever. Or like if you run the validation, so you will find the validation output here in this folder as well. If you do the evaluation, you will find the evaluation also in this folder. So everything related to the training, validation, evaluation process will be found here in this folder. Okay. For this reason, we need to create three of them. I have already the set that will help you to just make tier of the whole 5 folders. But yeah, if you already, if you want, we can, you can do it manually. But I think you can directly run these, and it will create the folders for you. Okay. Then what we need next is to export the folders or the path to the folders to the environment paths. Why? Because nnUnet doesn't wait for us to give the folders manually or the paths to the folders manually, but it takes them directly from the path from the environment paths. So you need to export them. If we are using Linux, so we use the command export. If we are using Windows, so we use the command set. So for us, since we are using Linux, then we will use these 3 commands. Okay, so we need to export the path where we have or where the 3 folders are located: the raw, preprocessed, and the results. Okay. After that, if you before going to the pre-process, if there is something that you will do, which is, for example, what I do most of the time, which is the renaming. This is one thing, but the renaming doesn't require the dbubble or pytorch or simple itk. But there is a step that I do, because sometimes some metadata in the between the scan and the segmentation are not the same, just small issues between them. Maybe whenever the annotators exported the annotation file, they forget to use the to check, for example, the reference volume or something like this. So some of the metadata, maybe the spacing, maybe the orientation, are not the same in the volume and in the segmentation. And if we go to the pre-process part, nnunet will not accept these files, even if there is 0.0.1 as an error. It will not take it. So they should be the same. For this reason, I have already a code that corrects these. So it will copy the metadata, which is the origin, spacing, orientation. It will copy them from the volume or the scan, and paste them in the segmentation, so that if any of the segmentations are not having the exact metadata as the scan, then we can correct them. So I have already, for the dataset that we'll use here, I have already corrected this, but the script or the code to do this, I have wrote it and included it in the repository, so you can find it and use it. If you are using different dataset, then I recommend you pass it by the script so that you can correct the metadata before going to nnunet. Because if nnunet finds only one case in your whole dataset that has this issue, the whole process will stop until you correct or you delete these cases. So to avoid any issues, you can run it at the beginning as a verification step. Okay. So after doing that, like to do that, you need to install a dbubble simple itk. For the PyTorch, I am just putting it here, but we not install it by pip install. You need to install it preferably from the website where you install the PyTorch plus the CUDA 12 preferably. And for the PyTorch, you need to install, like it is required to install 2 point something to run nnUnet. So I'm using 2.2, but if you prefer something else, you can use it, but you don't have to, like, you need to go like 2 point something or like 2.0 or larger. So before, like, smaller than that, it will not work as a version. Okay. Then here I am just showing you how you can do the splitting. So the data set that I have only 2 folders. I have one folder which is the volumes and one folder which is the segmentations. And to train the model of an unit, we will need 2 model. Like we need specific structure, which is the image testing, image training, label training, image testing, label testing, or maybe label testing. We can put it directly with the folder of the image testing. Sorry. So at least you should have 3 folders: one for the images of the training, one of the labels of the training, and one that contains labels and images for the testing. So this is the, like, at least the least what you need to have is that. So if you have just two folders, as I am doing, and the same dataset that I am sharing, it has only two folders, then you need to split it into train validation or train validation testing if you want to have another dataset that will be separated just for the testing. And just to mention something, the data that we will separate here will not be used for the validation, but it will be kept just for the testing or evaluation, because the validation dataset will be taken directly from the training dataset. So what I recommend, whenever you do the split, you do only two splits, one for the training and the other for the testing, and you put the maximum dataset in the training, because the ones that you will keep for testing will be left for testing only and will not be used for something else. This is what I recommend, but for sure you can do whatever you want with your dataset, but this is just a recommendation. And whenever you do the splitting, okay, we can do the renaming. And so the renaming, I have two ways to do it. Either you will run this rename dataset, or I have already created a class called dataset renamer. We'll come to that later, and I will show you how you can run it to rename your dataset to the nnunet structure. Okay, because as you may saw in your you may see in the documentation of nnunet, they are waiting for a specific dataset structure. So maybe I can go to the folder and show you directly what I am trying to say. So I have an nnunet. If I go, this is the official repository. So I think I am not sharing this window, so I think you cannot see it. Let me try to. Yeah, maybe I will try to stop the recording and start it again with the new with the other window. Okay, just 1 second. This is the repository from nnunet. So if we go to the data documentation, let's try to find the dataset format. So yeah, this is what they are waiting for. Here they are just talking about as I told you, in the raw folder, you will have this structure. We'll discuss it later, which is, for example, brain heart. If you have different data set that you will use for training, and also this is tricky. When you see this, you may think that you can train one model that does like all of them. So it is not the case. You can just have these, but when you do the training, each dataset will have specific model. So if you want to have one multi-class model, then you need to put all of them in one folder, which we can call multi-class or something like this. But you cannot have just one folder of this data set and another folder for another data set, and you have one model to treat these like all of them. This is not possible. They are just putting it here. If you have multiple data sets, you want to launch multiple trainings, you can already put them here, but you need to keep in mind that each folder or each dataset will have a specific model. Okay, then inside each one of them, you will have there is the JSON file. For JSON file, this is the JSON which is required. Without it, you cannot run preprocess or training. So it contains some information that we will discuss later. And then you will have the image training, the label training, and the image testing. This is an optional one, not required, but you can put it already so that we can use it for the evaluation later. Okay, and then this is the exact structure that the model is waiting for. So if we go to the image tr, which is the training, you will have these naming. You should have these exact naming. So this is what I was talking about. This is the first, like the we can say not the index, but it is no name of your data set. Let's say you are doing brain tumor segmentation. So for example, you can do it PRAT, and if you are doing liver, you can call it liver. So you can call it whatever you want, and then these are the indexes of the data set. And then you will have this part, which is sorry, just something I need to make sure. Yeah, then the idea here is that you have two types of indexes. You have these parts and you have these parts. Okay, and then you for the labels it should be something different. For the labels you have only the three indexes here. Why? Because the data set has like especially for the MRIs, for the CT scans we don't have this thing, but especially for the MRIs, if you are for example doing the brain tumor segmentation and you have the T1, T2, T3, and these are on the same scan. So sorry, in the same scan you will have different channels. So you have the T1, T2, T3. And in this case, whenever you are annotating your data set, you will have the first case, for example, the scan MRI, the first one, but you see here we have four times. So maybe it is T1, T2, T3, T4, but these second indexes are controlling the T1, T2, T3, T4. So it is from 0 to 3, but there are four studies here. But in the first part of the index, which is the most important one, which is the index for the scan. So if you go to the annotation, for example, you see that we don't, for annotation, we have just one mask for the four studies. So it will be always BRAT and 001, 002. So this is the scan. And this segmentation is for these four ones, because these four ones are the same scan, which is 01111, but different studies. And it should contain one annotation for the whole scan. And the same thing for the other scans. But if you are working on CT and even for the data that we will use for the course, it is just one study, one channel. So it will be just, for example, BRATS 001. But here we should leave it zero, like four zeros. But because we cannot delete it, we cannot just say, since we don't need it, we don't put it, because nnunet is still waiting for it, but it will be four zeros for the whole data set and for all the cases. So we don't care about these. For that, you just put them 000. But for these will be the number or the index of the scan. So the scan number 1, the scan number 2, scan number 3, etc., etc. So we will have the scans and we will have the labels. So this is how the data set should be created. And as I said, I have already the renamer that will do that, which is the dataset renamer. So we'll use it directly in our course. So I will run it and show you what it will generate. But yeah, now I am just going to the workflow and showing you what we will do. But after that, you will see that all the steps are easier if you have everything set up correctly. You don't need to care about that. Everything will be easy to run your training and to get your model and do evaluation. And after that, you can do whatever you want with the model. Okay. So now after creating the datasets, we can like install nnunet. Why I'm saying installing it, because when we start using it either for the pre-process or for the training, there are some commands that needs to be run, and these commands to be able to run them, we need to have nnunet installed. Some people install it by pip install. I don't prefer that, because I always like to run it from the source. So what you can see here is that I forked the repository. I did this just today. Why? For very big reason, because the nnunet team builders or the owners are all the time doing some updates, and sometimes just one update can affect the whole workflow. So what happened to me, for example, I had some models that has been trained, and when I wanted to, like old models, and I wanted to run them with the new inference code from nnunet, I couldn't, because the structure was different. And the same thing for the training. So if you like, let's say you had a model trained, let's say in 1 month, you want to do inference now, you cannot do that. And if, for example, you train a model now and you want to use your inference code that has been built 1 month ago, so it will not work, because there are two different ways they are exporting the model network, and they are exporting the model weight. So it is separate or different from what we were doing 1 month ago. For this reason, to avoid any issues, I forked this version, so that this version will be always an old one that is working with the specific video that we are recording now. So if you see the video 1 year from now or a few months from now, and you want to do the same steps, you will not have issues, because this version is stored in my GitHub repository, and I will not touch it. I will not update it. Even if nnunet will update their code, then I will not touch it, so that whenever you run the code, it should work for you. Okay, so this is just to avoid any issues if you prefer to always use the new version of nnunet. So I cannot guarantee that the same steps that we will see in this video will work. Okay, and yeah, this is just to install it, and we have this other module, hidden layer. It is not required but recommended to be installed. I saw it in your documentation. You can also read the documentation here and see what they say about this. And then after that, we need to create the dataset.json file that I told you about, that is we saw in the documentation. It shouldn't contain a lot of things. It just should contain the modality of the dataset. If you have multiple modalities, then you can put 0 CT, 1 MRI, 2 PET, etc., etc. But for us, we have just CT, so we have 0, which is the first modality, and the name is CT. And then we have the labels. So we have 25 labels, like 26 with the background. These are the labels that we have in our data sets. And also you need to put the number of the training data set. So whenever you do this, we have about 1,000, I think, the whole number. But whenever you do the split for the training, validation, testing, and vice versa, you will find, for us, it was 762. But this is just a template, let's say. Whenever we go to the training, we can always recalculate how many cases we have, and then we can use that number for this dataset.json. And then you can specify what is the dataset that you have, like the ending or the extension. For the data that I have, which is Nifty and Nifty.gz, the compressed ones. If you have just NII, you can put NII. If you have NRRD, you can change it. And yeah, this is for me. I am putting it like this because the dataset is compressed Nifty files. And then here, I don't care a lot about this because they are just thinking about like what do you prefer to use as a reader and writer. I don't know what are the options that they have, but most of the time on my projects I use simple ITK. For this reason, I didn't change it. But if you want to check what is the list of the readers and writers that they have, you can already check that and change if you prefer. Okay, and then whenever we are in this step, then we can say that most of the hard work has been done. Just what we need to do is to run the training and run the pre-process and run the training. So to run the pre-process, there is this command that we will discuss later. You just run it to do the whole pre-process of your dataset. If your dataset is large, it may take some time. If your dataset is not very large, so it may take just 30 minutes, something like this. Otherwise, it can take a few hours. It depends to your data set. And then whenever you complete the data set, the pre-process, you can run the training with this command as well. And the training also depends on your data set. If you have large data set, then it may take a lot of time. Otherwise, it can take a few hours. But I think at least it will be 3 hours something to complete the whole training for the 250 epochs. Okay. Yeah, and then whenever you complete the training, you do have your model. So you either run the prediction to predict the masks using your new model. You can run the evaluation. After the prediction, you can run the evaluation to evaluate your models. Here, when you have the ground truth and you have the segmentation, you do the evaluation of your folder. And yeah, after that, you can use your model to do whatever you want. So, for example, let me just show you the data set structure that we have. So this is one case of the whole data set. It is a CT scan, and this is what we are trying to segment, and we will get something like this as an output. So let's hope that we can achieve something that looks like this. And yeah, for sure the models always needs refinement, but let's see what nnunet can give at the first shot. I have already trained the model myself, but we'll redo it again here in the video and see what it gives. So this was so this was about the introduction of, or what are the steps that we will see in this video. And as I said, I will share this with you if you prefer after the video. And yeah, we'll do the steps. Some steps we can write some code if necessary, and other steps we'll just run some existing code And if you have questions, you can always leave them in the comments. Now let's work on the other part, which is how to set up a server. So if you don't have a good server or good machine in your either in your local PC or on your lab or your on your company, and you are trying to find the best affordable cloud provider for GPUs, so I will recommend Vast AI. I used it for several projects, and I found out it is the best one in terms of good GPUs, and there is always available GPUs and like available instances, and also it is very cheap compared to GCP or Lambda or AWS or the other cloud providers. So I found that this one is the best. This is my personal experience, but maybe if some of you had already other recommendations, I would love to hear them. You can always leave them in the comments, and we can try them for other videos. Okay, so whenever you are in your VAS AI console, so what you need to do is to I need to sign in. For me, I have already account, so I will sign in. If you don't have an account, then you need to create your account. So I am just signing in. Yes. Okay. So in my credit, I have $58. So you can, if you don't have it, you need to have some credit here. You can add your credit card and or your Visa card, and then you will add some payments here. I think you should have at least $50 to create an instance. I am not sure about this, but for me, whenever I have the $50, I cannot use the instances. I need to increase it. For me, I am putting it to be increased automatically, so I don't need to care about this a lot. But for you, if you don't want to increase it automatically, but you need to be careful if there is any data in your instance, then it will be deleted. So you need to be careful about that. Okay. So whenever we complete, we have the account. You need to check for an instance that will work for you. There are a lot of configurations, so you can check whatever you want, and depends to the data set that you have, depends to how long you want to allocate the instance, because you need to keep in mind that these instances doesn't like you don't have lifetime access. So sometimes some instances have, for example, this one has 20 days, so you can allocate it for 20 days at most. This one is for 5 days, this one is for 1 month, 6 days, depends to the instance. This is a good way maybe so that no one will take an instance and leave it, just reserve it for 1 year, maybe if he doesn't use it or he doesn't need it. So preferably you can use the instances like these, especially for the training. I don't recommend using these for production, like you deploy a model on this, because the instance will be closed in 5 days, for example, and this will not be good for your product. So you need to create an instance each time, and which is not recommended. So you will use this only for the training. And also, if you know that your training will take more than 5 days, then I don't recommend taking this, because like you will lose the instance before completing your training. Don't worry about nnunet, and with the course we will not surpass the 5 days. It will be just 2 or 3 days as maximum if we take a lot of time. But you can do everything in one day if you do like the process step by step. Then you don't need to care about the 5 days. Okay, so this is for the people who will use the VAS AI. If you don't want to use it, then you can skip the whole part here. Okay, so let me just rent, for example, this one. There are cheaper ones. I think this one is cheaper. Yeah, this one is cheaper, but since I will not allocate it for a long time, so I don't need to care about that. Also, before allocating, you need to specify the space that you want, disk space, the storage. So I will put, for example, 436 gigabyte, and then let me search for cheap one. Okay, so we have this one. It is cheap, and okay, it is 60 GB. I will try to find like 24 GB. Tak, tak, 60. Let me just, because sometimes you can find just like for $0.3, you can find 24 GB and it can do whatever you want. So let's check this one. Yeah, okay, let's take this one. So it's like 0.39 dollars per hour. So it has a 40 GB GPU. So I think this will do the job. So let's take rent this one. Okay, continue. Okay, if we go to instances, it is being created. Just wait for a few seconds. Okay, so now the instance is ready. Let's open it. Okay, the first time we need to authorize it. Okay, so now we have our workspace. I don't know if this screen is shared or not. Let me just stop recording and we'll start it again. Just 1 minute. By the way, if you are a medical imaging student or practitioner and you are looking for someone to help you to create your deep learning models for medical imaging analysis and desktop applications also, you can always contact us. We do consulting for this for the field, and we can help you build your deep learning models and customized architectures, customized desktop application for your purpose. So don't hesitate to contact us at contact@pycad.co, and you can also see some of our works at pycad.co/portfolio. Okay, so sorry about that. I'm using a new tool for the recording, so I am struggling a little bit with the new tabs. So okay, let's just get back to our course. So as you can see here, we are in our workspace. So whenever you complete this and you open the instance, it will be something like this. It is kind of Jupyter notebook, but you can create Python codes. You can create, you can open terminals and use them. And yeah, I think let me just take this here. Uh, okay, let me just move it somewhere just here. Okay, and for the workspace here, what you need to do, you don't need to care about all these. Just go to the workspace. Here we'll do all our job. We'll create the folders. We'll do whatever we want. But before that, there are some setup that we need to do. The first thing is to initialize Conda so that we can create a Conda environment, and the other thing is that to just do some update to the system. Just this is just for this instance. So if you are using your own server, so you don't need to do this. But if you are using the vast AI instances, so you need to do these steps. Okay. So as I said, the first step is to let me just open this. Okay, so this is the terminal. Let me just initialize Conda. So we have Conda in it. So now it is showing that it has been initialized. I can create a Conda environment, but I will not be able to run it. Let me just show you here. So we have Conda create. Then let's call it nnUNet VN, for example. Okay, let's just create it. Yes. Okay, now if I want to activate it, I want to be able. Let me just show you. nnUNet VN. Yes, you can see that it is not recognizing the command activate, which is strange. So what you can do, we just need to close the instance, okay, and reopen it again. And now it should work. Otherwise, we'll restart the server. But just by closing it and opening it, it should work. But let's just say see what happens. And as I said, this step is just for vast AI. If you are using your own servers, then you don't need to care about this. Okay, so now since you see the base here, this means that Conda is working correctly now. So if I activate my created environment, so nnUNet VN, now it can be created. Okay, so this was the first thing. The second thing is that we just need to update the server, the system, and install the nzip because it is not recognized in this server. So let's just go here and paste it. Allow pasting. Okay, and let's run everything here because whenever we will download the dataset, we'll need to unzip it, and the unzip command will not work if we don't install it. So it is not installed by default. Okay, so this is how to set up the server. Now the server is ready. What we can do now, we can start downloading the dataset. We can start doing the renaming, the pre-process, and all of that. So I will just keep it to another section of the course. So yeah, this is for this for the server. And as I said, if you do have a server, you don't need to see all these steps. Let's discuss how we can access the dataset that will be used for the course. So there are two ways of getting the dataset. The first way, that will be lifetime. So I am putting it in Kaggle. So I will leave the link in the description. So if you go to Kaggle and search for spine segmentation from CT scans, you will find this dataset that I have uploaded here. So I am still mentioning the original provider, because this dataset is from the total segmented dataset. It is not mine. So I am just hosting it here, but the whole, if you want to cite the dataset, then you need to cite the original provider, which is here. Okay. And yeah, apart from that, like, I'm just using Kaggle to make the dataset easy and accessible. The other way where I am putting the dataset is in my Dropbox, which I will use in the course. I will show you how to download it. But the dataset in my Dropbox will not, like, I will not leave it there for lifetime, maybe in 1 or 2 years. So if you are seeing this video after 2 years, 2 years, or maybe just 1 year from now, maybe the dataset is not accessible from my Dropbox, but it will be still available in Kaggle. Okay, so if you try to access it from Dropbox and you see that it is not working or it is not available anymore, then you need to see the Kaggle page of the dataset and download it from here. Okay, so yeah, this is a dataset, but I will show you how I will download it from my Dropbox, so that it will be easy to download it. But if you prefer downloading it from how do we call it? If you prefer downloading it from Kaggle, then you can go and do that. Okay, or for sure, if you are using your own dataset and not my dataset, then for sure you need to see how to get it accessible in your workspace, which is either here in Vast AI or on your own server. Okay, so here I will just download the dataset. So I will change the directory to workspace, where we are working and doing all our coding. So for now we didn't do that, but we will be working on this directory, which is workspace. So it will be a little bit clean. Now what we need to do, we'll just create a folder called datasets, okay, where we will store our datasets. Then let's go to the folder dataset. Now I will just copy and paste the command which contains the link to the dataset in my Dropbox. So this is the link to the dataset in my Dropbox. But as I said, this is not something that will be for lifetime. You can still try it. If it downloads datasets, then okay. Otherwise, you can search for it in Kaggle. Okay, but I will leave also this command in the GitHub repository. So if you want to access it and if it is still available, then you can use the command. Okay, let me just run it. There is something here. Yeah, I think it is still downloading, but it's redirected the download to this logs file. Okay, so you just open it and see the progress. Okay, so it is still downloading. I will just pause the video for 1 or 2 minutes until the download is completed, and then we can take it from there. So now we have the dataset that has been downloaded successfully, which is this file. So I think this one we can already close it. Okay, so we don't need this anymore. We will need the terminal, but we don't need the command. Now I will just rename it, because as you can see, this is the name of the file until zip. Then we have this part which is from the URL from Dropbox. So we'll just rename it so that I can unzip the file. Okay, let me just delete until here. Okay, so this is the file, the zipped file that contains our dataset. We can unzip it directly here. So we just have unzip and then the name of the file, which is spine segmentation v2. So it is being unzipped. It will not take a long time. Just wait. Okay. Let's pause the video for a few seconds. Okay, so the dataset is unzipped, and we have now the folder. Let me just refresh. We have the folder here that contains the volumes and the segmentations. Okay, now what I will do, I will just create the folders that we discussed before, which are the folders for the nnunet row, nnunet preprocess, and nnunet results. Okay, and also we'll have just one folder that will be called nnunet data. This will help us structure all the or organize all the folders for nnunet in one place. So as you remember at the beginning of the video, like of the whole course, I showed you how to like the whole process. So I showed you the steps. So I am just following the steps, and also I will share the steps with you later. So this is how it should be done. Let me just go one step back, and now these are the different steps. Let me just move this. Okay, so these are the different steps. We will make a directory that contains this is the nunit data set or data. Then we'll have the nunit row, nunit preprocessed, and then nunit results. So these are the folders that we would need. Now let me just create them. Sorry, I am just adding because these commands has been used in my notebook. For this reason, it seems to have the other sign. Let me just correct this. As you can see, like the video, I am trying to use the video as spontaneous as possible, so that I don't make things that, like, maybe I can make some mistakes in the code or mistakes in the process, and this will be helpful for all of us, so that we can understand why some things are not working and we can correct them in real time. So yeah, I have to create this folder first. So exist. Okay, so maybe I will just cd to the data sets and then do it manually. So I have an nnunet data exists. I didn't know that it exists. Why is that? So it created it even though the command was wrong, but this is strange, but okay. So we have the folders now, we have the data set, then we have any data set data, and then we have the three folders. Okay, so now what we need to do, we need to export these folders, but it's not a step that we need now to export the folders, the paths to the folders in the path environment. But for the moment, we don't really need it as of now, because we'll do other things before going to the nnunet part. So let's just leave it, because what you need to keep in mind, if you are working on a server or something and you close your window and you open it again, then all what you have exported as a path environment will be lost. So you need to re-export it again. And since we are not going to use it now, why should we export it and then we need to redo it again? So for the moment, we just leave it now. We created the folders. What we need to do is to, like, now we can start working on the other part, which is how to do the splitting and how to rename the data set. Okay, so this, I will stop this video, and in the next video we'll do that. We'll just do the splitting and renaming the files into the nnunet format. So the next step, as I said, is to do the data splitting and the renaming. Okay, so in this folder, in the workspace folder, I added a folder called utils that contains this dataset Python file. I will just open it and show you what it contains. So there are some modules that we will use now and other modules that has been used before, like before the course, to prepare the dataset. So I just put them here in case you will need them for your specific dataset. So the first thing that we will not use for this course directly, but you may need it for your dataset, which is like multi-class Nifty merger, which means if you have separate Nifty files for your classes, so let's say you have more than two classes in your dataset, and you received it as different nifty files or separate nifty files for each class, and you need to merge them into one nifty file that contains all the classes. So in this case, you need to use this. You can use it if you have something else, then of course, but if you don't have it, you can use this multi-class nifty merger. So it is a module from the PyCAD library. You can use directly the PyCAD library if you have it already installed. Otherwise, if you don't have it installed, don't worry about it, because it contains a lot of things that maybe are not needed for your case. So you don't need to install the whole library just for this module, for example. But if you prefer, you can directly take a look into it. Maybe you will find other things that will be useful for your case. Okay, so we have the multi-class nifty merger. Then the other thing that we have also is the data splitter. This is also from the PyCAD library, and we will use it directly. I just copied the modules and paste them here to make the course easier. But for you, if you prefer seeing the whole library, you can go into it and look to the other examples. And then we have the metadata copier. So this one is not from the PyCAD library, and this one is the module that I used to copy the metadata from the scans to the segmentation or to the annotations. So as you remember, at the beginning of the course, we discussed this part, which is how to copy the metadata from the scan and paste it into the segmentation. Why we do this? In case the metadata in the segmentation has been corrupted in the export part, for example, when the annotators did the segmentation, and they didn't save correctly the segmentations. So nnunet will not accept that. Even if you have one file with this issue, it will not be taken in consideration. So I use this to make sure that both of the files has the same metadata. So if you are using my dataset, then you don't need to run this, because I have already run it before uploading the cases to Dropbox or to Kaggle. But if you don't have it, so if you are using another dataset, so I recommend running this so that you make sure that you don't have any issue. Otherwise, if you are pretty sure that you don't have this issue between the scan and the schematation, then you can ignore this part. Okay, then I have the data renamer. This is not something in the PyCAD library, so I am just using it to rename the dataset, and this is the one that will create the nnunet structure. So if we run this, we will get the folders like the train images training, images testing, and labels training. So these are the folders that will be used to train and to evaluate the nnunet model. Okay. Now, after that, we have all these ready. I will also attach everything that you are seeing here in the GitHub repository. Don't worry about that. Now we will use them. Okay. So before going to the use case, we need to install a few libraries. Let me just copy this here to install a few libraries that we discussed also in the steps when we discussed them at the beginning. So we have the debubble. So I will just copy the versions. So we have pip install here. I am putting this specific version because maybe you can see the video after 1 year from now. So I don't know if the newest versions can work or not, but just in case, I am just putting the exact versions that I am using now. So if you face any issue, you can downgrade to this version and it should work. Okay. Now let me install the debubble. Then we have another library, which is the simple ITK. So also I am attaching the version. So it is like 2.3.1. So I will just install it. The other thing that you will need, which is PyTorch, as I am using the Vast AI server, it has already PyTorch 2 point something. It is 2.2.0 installed. But for your case, if you prefer installing it, you can go to the official. Sorry, you can go to the official website and just copy the I don't recommend installing PyTorch just by pip install torch or just pip install PyTorch, but I prefer going to the exact website and copy the exact command. So for example, we have Linux. I prefer installing it by conda, not by pip, and then you choose which version. Preferably should take, like for now I am using the CUDA 12, so you can select the 12. If you have the 11.8, for example, you can take the 11, and vice versa. Or if you have older version, you can see. But as I said, the nnunet requires 2 point something. version of PyTorch, so it should be 2 point something. So yeah, just copy the command and run it. It will install the PyTorch for you. Okay. For me, I don't need to redo it because it is by default installed in the server. So yeah, we have it. Now let me just clean the server, the part here. What we need to do now is to run or to do the splitting. So we need to split the data set. What we need to do is to go to there are two ways, like either we use the Python editor directly in terminal, which is not the best way, or we create a Jupyter notebook and we work there. But the issue that will happen is that not we are not sure that the Jupyter notebook that we will use is attached to the Conda environment. So this can be an issue. So if we need any of the other libraries, this may not work. But let's just try if there is any issue. Otherwise, because most of the time what I do, if I know that this is temporary server, I don't even create a Conda environment. I work on the base, which means whenever I create any new terminal, new folder, new Jupyter notebook, they all of them pointing to the base environment. So I don't need to care about which environment I am pointing to. But as I said, this is something that's up to you, how you want to organize your workflow. So I will just come, because to do the splitting and to do the renaming will not require the other libraries that are not by default installed with Python. So for example, we have the OS and glob, so you don't need to care about this. So let's try to work. If there is any issue, we can think of something else. As I said, I am just running the code with you, so if any issue will happen, we will try to figure out how to solve it together. Okay, so let me just create a Jupyter notebook here. Let's open it. Okay. Let me just rename it into something like spine segmentation, just something like this. Okay, and now let's do the first part, which is the splitting. So I will just copy and paste here the exact command that I showed you in the steps. So we have the splitter that is imported from the utils. As you may know here, sorry, in the utils here we have why the okay, in the utils now here we have the files that we have, which are data sets. Okay, so from utils, why I am just importing it not from data sets, because in the utils we have this init file that is helping to import the classes directly without using like utils.dataset import dataset splitter or dataset renamer. But we are just doing from utils import these, because in the init we are adding this line that will help us to import the files directly from the utils and not from the datasets. We are making the whole folder utils as a module and not as a folder with these commands. Okay, so let me just now go back to the course. Now here, as I said, we have the folder workspace, and then we have the folder datasets, and then we have the spine and nnunet the spine segmentation and nnUNetv2 datasets. So if we go here, we have dataset, the spine, and then we should have volumes, we have segmentations, and we have the split. So the split, this is the new output folder that will contain the split images and labels. Okay, now I just need to change here because it is v2. It is separate than the one that I tried before. I had an issue before. For this reason, I created a new version. I called this v2, and the same thing here, and the same thing for the last one. Okay, now we have the three parts. The first one pointing to the volume, second one to segmentation, and last one to the output. Okay, so I'm creating the split 0.7, 0.2, 0.1. This is just my choice. This is not something general. I'm just trying to use some, because as I said, the training data, because this is the training, this is validation, and this is the testing. So the training data will be used for the training, and the parts from it will be used for the validation. This part, which we are classifying as validation, we will use it for testing, and this one we can leave it like just a small portion. We can leave it just at the end if we need it for something else, for just testing our product or something. But as I said, this is my own splitting process. But if you want to use something else, please go ahead and do that. So yeah, as I said, it is true that we are doing three splits, but in reality it will be four at the end, because this training will be already two splits for nnUnet plus these two. Okay, so I will try to run it and see if there is any issue. Yes, of course, there is an issue. So dataset renamer, it cannot be imported. Let me just check in the folder if there is anything we missed in the utils. Dataset renamer. Let me just see if we are using the exact name here. The data renamer. So I think this is the issue. Let me just recheck what is the name of the module exactly. So it is just an issue with the naming of the modules, because sometimes I change some things and I forget to update them everywhere. So let me just verify the data set. Yeah, it is data renamer and not dataset renamer. So I am making an issue or an error in the import. So let me just close this and this. So here it is data renamer and not dataset renamer. Okay, now let's run it. Okay, it is working. Let's see if the folder splitter has been created. Datasets. This one. Yes, we have the split folder created. Yeah, it is done. So what I did here, I am activating this flag that I am putting like delete input, which means the first input that we had, which are the folder of volumes and segmentation, I have deleted them. If you don't want to delete them, you can put this as false so that you don't lose your input files. Why I'm doing this? Because I know that they are the same files. We are just copying them. So why should I leave the input files? Like I will lose storage in the server. So I delete them. Okay. Otherwise, if you don't want, you can leave them. And also, by the way, we can delete this. We don't need this anymore. Okay, so now we have the splits and we have the test, train, and valid. So validation, training, testing. And in each one of them, we have the labels and sorry, the images and the labels. Okay, so for each one of the folders, we have this. Okay, now we did complete this part. What we need to do now is to do the renaming. So we need to rename the folders or rename the files that we have in our data sets. So we need to put them in a structure that will be recognized by nnunet. So this is the next step that we'll do now. And yeah, we should do it at the same Jupyter notebook. So let me just copy the command and we can use it. So let me just start by defining the input folder, which is for us, it will be just this folder. So I will just copy it and paste it here. So this will be the input folder to our renamer, because in this folder we have the new data set. Okay. Then what we have, again, we have the folder where we will save the new the renamed data set. So to do that, I will just copy it here and I will show you the new folder that we'll use to save the dataset, as I said, which will be in the nnunet data, and then we have the nnunet row, which will contain the input data to nnunet. So we should put it here. We don't have another choice. Of course, this part you can choose whatever you want, but at the end we should put it in the folder nnunet row that we created. Okay, now we need just to call the module. I will copy it and paste it here. Now we have the data renamer. It takes mostly 4 parameters. The first parameter that we have, which is it should be the input. I will just to not confuse you, but something like this. So this it should be it should take the input folder that will contain the images, like for the training, validation, and testing, because you need to use the splits, because the script that I am using here, which is the renamer in the utils, it is waiting for the image. Let me just open it here. I built it so that it will be used just after the splitter. So the output of the splitter exactly will be taken to in consideration in the renamer. So let me just go to the renamer. Yeah. So the renamer, as you can see, it is waiting for the train and the valid, so images, labels for both of them. So the output folder of the train of the splitter is the input to this data renamer. So if you are not using my splitter, so you need to make sure that you need to update these files, these folders here. Like these are the input folders. This is the only thing that you need to change if you are not using my splitter. Otherwise, you can just use the splitter, and the output of the splitter will be the input of this renamer. Okay, so yeah, as I said, we have the folders data set, and we have nnUNet data, and this is the nnUNet row here where we should store the output file that we have. The third parameter, which is the index or the ID. So nnUNet has this notion of the ID. So whenever you have a data set that you will use for training, you should give it an ID that has three characters. So it should be from 000 to 9999, 999, sorry, 999. So this, you should choose just a number between that. It doesn't matter. The only thing that you should keep in mind is that if you have different data set that you are using, so you are using, for example, the same server to train different data sets and different models. So all of them will be stored in the nnUNet row, but you just need to make sure that they don't have the same index or the same ID. So if you have, let's say, 100 data sets, so you should have different 100 different IDs. Okay, but if you are just using one type of data set, you can just choose an ID. I am choosing 100. It is just a random choice. You can choose whatever you want between 000 and 999. Okay, the other thing, which is the name of the data set, which is, for example, I am calling it spine. You can call it whatever you want. If you have liver, you can call it liver. If you have, like, you just call it whatever you want. This is just the name of the data set. But whatever you give here, you need to keep it in mind. And this, the most important thing also is the ID, because you will see that we will need it for any step later. So whatever ID you put here, you need to keep it in mind because you will need it after. Okay, even if you forget it, you can find it in the folder and a unit row. The folders will be created of your dataset will contain the name, will contain the ID that you choose here. Okay, let me run it and see the whole process. So the whole process is happening here. Okay, let's just wait until it completes. Okay, so the process is done. Now, as you can see in the nnUNet row, we have this new folder that has been created, which is dataset 100. So as you remember, this 100 is the ID that we choose here. So we have the 100, then underscore, and we have the name of the dataset, which is spine, that we choose here. Okay, so if you, let's say, you don't remember what ID or what index you choose here, you can just go to the nnUNet row and you find it here. So you need to keep it in mind, this number, you will need it later. Okay, so now we have most of the things ready for our training. So before the training, we have the pre-process, but the most important part, which is this part, which is creating this data set. The other thing that we'll need, which is the number of cases that we have for the training, so that we use them to create the dataset.json file. So let me just go and calculate how many cases do we have, and then we can go to the other step, which is creating the JSON file, and then after that we can set up the nnUNet and go after that. Okay, so let's just go in the terminal and let's go to cd dataset, cd nnUNet dataset, let's cd nnUNet row dataset, then cd, I think, yeah. Then now we have the image training, image labels, and image testing. So let's go to image training, let's say. Okay, so now we have the folder that contains the images. So I think there is a command like ls minus one, I remember. Then this wc minus l, I think. Yeah, this command will return the number of cases that we have in this folder. So it is 762. So what we will do, we create a JSON file that which is dataset.json. It should be named as dataset.json. That will contain all the information that we need, which we explained at the beginning in the steps. So which are the name of the datasets, like the modality, which is the city, then the labels, which are the labels of each index or each class of our dataset, then the number of the training dataset, then the file ending, and the module that will be used to read and write the dataset. So I will just copy it from the file that I showed you the steps. Now we can go and create it. So the file that needs to be created, it needs to be created here inside the dataset 100 spine. So here we need to create a new JSON file and give it the file content. But unfortunately, I don't know why, but in this specific server, I cannot open a file, a JSON file, and edit it. So I need to do it outside the server and just upload it. So let me just search for the file and then I will upload it directly there. So let me just see here in my local. Uh, Here, coding, spine, utils. Okay, so I have it. I will just upload the file, and also the file that I will use here, I will leave it in the GitHub repository in case you want to use it. You just need to upload it. So this is the file. Let me just open it. Why I didn't edit it directly here, because I don't have access to upload to edit a JSON file. I don't know why, but let me just open it. Okay, so yeah, this is our JSON file. As I said, we have the modality, which is CT scan, the labels, which are the classes that we have. We should give the name, then the index of the class, and then we have the number of training cases, which are 762, and then the ending of the file, which is .nii.gz, and the image writer reader, which is simple ITK. Okay, now this is done. What we need to do in the next steps, which are installing the nnUnet and its dependencies, and then we can go to the pre-process part. Let's delve to the installation of the requirement. So the first thing that we'll install, maybe it can be the first and the last thing, which is the nnUnet model or framework. Actually, it is not specifically a model, but it's a framework, because it is just a unit, but with different or with automated configuration for the model architecture, for the hyperparameters, and for the pre-process arguments. So, but at the end of the day, it is just a unit. For this, they call it an unit, so not a new unit, but at the end it is the same logic, but with automated configurations. Okay, so as you can see here, I forked the repository here. Why I am forking it? Because like I am trying to protect the video with the and the unit version that we'll use at this day. Why? Because the developers of nnUnet make changes like all the time, so which is a good thing, which is not a bad thing. But the only issue that can happen is that if you are seeing this video and using the exact code and exact commands that I will be using now, maybe it will work today, maybe it will not work next month or next year. So to avoid any issue in terms of updates, I am just forking this repo. So I will just leave it, I will not touch it or update it. I will leave it just like this, so that if you fork this exact repo and use the exact instructions that I will show in the course, then it will work either today or tomorrow or next year. Okay, so this is just to protect the versions between the YouTube video or YouTube course that we are doing and the version of nnUnet. Okay, so as I said, we'll install it. So the first thing that we'll do, we need to clone the repository, then install it. So I have already the commands to do that. If you remember, we have seen this in our first day when we discussed the structure, the course structure or the course steps. So let me just go back to the workspace now. Okay, just one step back. Okay, so now we are in the workspace. What we can do, let's just, the first thing that will happen is to clone the repository, then we cd to the repository, then we install the framework using the pip install -e point, which is, we'll use the setup file in the nnunet repository to install the nnunet. Okay, so let me just paste it here. So we are cloning the repo, cd to change the directory to the nnunet, and then installing whatever we have in the setup. Okay, so yeah, it is cloning. It will take just a few seconds. It's not something that will take a lot of time. And yeah, it is installing now. Let me just move this. Okay. Okay, just a few seconds. All right, so it is done. So let me just clear and cd here. Okay, now we have installed the nnunet. In the nnunet repository, in the installation instructions, they have recommended to install a module called hidden layers. It is not required, but it is optional and recommended. So let's just do it. We don't have anything to lose. So I'm just installing it here. Let's wait until it completes everything. Okay, great. Now we have the setup installed. What we need to do is to export the path environments. If you remember, whenever we created the folders, I said that at one step, at one day, we will need to do this export. So I will just do it now so that you see that there is no issue. So I will just copy the commands. So if you are using the, let me just re-show you again here. So if you are using the Linux, then you need to use export. If you are using Windows, then you need to use set. Okay. So I will just copy it and okay, I will just copy the commands and paste them here. So I'm exporting the path to the nnunet row, the path to nnunet preprocessed, and to the results. Okay, let's export them. Okay, now no issue. Now, as you can see, we have everything set up. Now, what we can do, we can start doing the pre-process and doing the training. So, yeah, this is almost done. Whenever we launch the pre-process, it will take a few times. So we will just run it and wait until it completes. Then after that, we'll run the training command and wait until it completes. Okay. So let's start by the pre-process. I will just copy the command and explain it. So here, paste. Now, as you can see, I am using the no hub at the beginning of the command just to make the command running in the backend, so that if, for example, I want to turn off my PC, then I don't need to wait. Because if you don't use this no hub before your command, then you need to leave the PC open and the Windows needs to be opened until the process is completed. But since maybe the process can take a lot of time, so for my case with this data set, it will not take more than 30 or 40 minutes, but sometimes it can take hours, especially for the training. So in this case, preferably you need to use this so that it can be run in the backend and you can turn off your PC and do whatever you want after. Okay, but now I need to change a few things. So the as I said, this one is to run the process in the backend. Then we have the nnUNetv2 plan and process. So this is the command that will run the pre-process and to prepare the whole argument for the training. So it will find what is the best architecture for the model, what are the best hyperparameters for the specific data set, and then what are the perfect spacing, the perfect orientation, the perfect window level and window center. So all these will be defined by the pre-process and plan. So this will find what is the best configuration for the model. So this is the thing about nnunet, which is it finds the best configuration for your specific data set. And even for the same data set, if you run it multiple times with the same data set, with the same arguments that we use here, you cannot guarantee that you will have the same architecture and the same pre-processed argument. So you need to be careful about this. If you are doing let's say FDA, or if you are applying for FDA or something like this, then you need to be sure that there are, because there are in their repository they recommend there are some things that you can make them as constant, so that even if you retrain your model on several times, some things will not be changed. Why I'm saying this? Because you can train your model now, and maybe whenever you get more data sets, you want to just refine your model. You don't want to change the architecture, or you don't want to change any uh, pre-processed argument. So in this case, you need to make them constant. You just need to fine tune the model on the new large data set. So in this case, you need to make sure that the parameters that can be changed in the plan and pre-process and in the training also needs to be constant. Okay, so but for the purpose of this course, we are just running the commands. For all the details about these different things, you can either contact the and unit owners, or you can contact us, as we are a company that build medical image solutions for companies. So you can contact us and we can get in touch and discuss your project closely. Okay, so yeah, this is the command that we'll use. As I said, this is the exact command to run the pre-process and to plan for your model. Then here I need to change this minus d, which means what is the data set that we want to train. In our case, we have, if you remember the ID that we used for our data set, the spine, it was the 100. So we need to put 100. If we don't use the 100, we use something else, then it will not find our data set. And of course, we cannot train them. And it will give you an error at the beginning. So don't worry about that. And then we have the minus C, which is which configuration we want to do. So for me, I want to train the 3D full resolution, because they have multiple configurations. They have 2D full res, 2D low res, I think, and they have 3D full res, 3D low res, and 3D cascade. So for me, I like, if you don't specify this, it will do the pre-process and configuration for all the different available configurations, which may make the process very very slow, and it will take a lot of time to complete. And since for me, I don't need all of them, I need just the 3D full res, then I do just the 3D full res. If for you you need more, then you can, if you, for example, you need only two, then you can make a list, put the two of them. If you need all of them, then you need just to delete this parameter, which is minus C, which is for the configuration, and you leave it to do the pre-process and the planning for all the available configs. Okay. Then here we have the verified data set integrity. So it will verify the data set, and this is what I told you about, which is about the spacing, orientation, if they are the same, if there is any issue. So this can be detected by this parameter. And then number of process that we have. So this depends to your hardware. If you have bigger CPUs, especially because this uses a lot of CPU in this case. If you have big CPU, so you can run 3 4 processes at the same time. For me, so that I don't want to crash my server, I am just putting it to 1, which is the minimum. So if you have larger or bigger resources, you can try with more than 1, and hopefully it works. Otherwise, if you see that your server or your PC is crashing, then you need to decrease it to 1. So now we have everything there. Just for the purpose of the course, I will just delete the no-hub, so that we will see the progress directly here in the terminal. Okay, let's run it. And let's see if it will find the dataset. So as you can see, it found the dataset 100 spine, which is our dataset. If I put, let's say, 200, it will not start, and it will give us an error because it cannot find any datasets with the index 200. So yeah, now we started this. It will take some time. I will stop the video until it completes. Whenever the pre-process is done for you and for me, whenever it is done, I will show you what has been created, and we can go to the training process. As you can see, the pre-process has been done. So I don't know if you did have any issue with your dataset, but as you can see here, for me, I don't have any issue. I don't know what is this window, but yeah, no worries. So for the dataset that I had, if you follow the same process that I did, you should be at this point, which is the whole pre-processing is done. and you have your dataset ready for the training. But if you face any issue, especially if you have your specific dataset, not the one that I used, so please make sure that you check if there is any issue with some cases. Then you need to maybe do copy and paste the metadata or something like this. But yeah, if you are in this stage, then you are almost ready to go. We can go to this to the folder and see what has been generated. So as you know, remember the nnunet row contains the dataset of that, like the row dataset that we had at the beginning. And now if you go to the folder nnunet preprocessed, you will find this same name, dataset 100 spine, and you will find these files which are nnunet plans and JSON and dataset fingerprint. Then you have the nnunet 3D full res. These are the configs that you will have and the dataset that you will have for your training. So this, as you can see, they are NumPy files and pickle files, which are files that will be used for the training. So these are the pre-processed dataset that will be used directly for the training. And you don't need to understand everything. Only if you want to know all the details, then you may check the documentation that contains everything. But if you are in this stage, then this means that you are ready to do the training. So now what we can do, we can use the, let me just clean the terminal. Now you can use the, how do you call it, the server to train your model. So there is a special command for that. Let me just show it to you. As you can see here, we have this command that will be used to do the training. So I'm always using the no hub to do the training. And then you have the nnUNetv2 train, and then 100, which is the index of your dataset. And since we are using the 100, then we need to keep it 100 here. Then we have, you need to select which model you want to use. And since for us, the config that we used before is the 3D full res, then you should put the same thing. And then here there is the fold part. So this fold part is interesting. So nnunet by default, whenever you have, as you remember, I told you that the validation dataset will be chosen by nnunet. So here is the part that is explaining this, because nnunet by default it splits the training data into five sets. So when you do the validation, you can choose either choosing the first set, like the first 1/5 of the data set to be used for validation, which is the index 0. If you want to check this to use the second one, then you need to put 1, 2, 3, and 4. Or if you want to use the whole data set for the training and for the validation, then you need to put all. So you just put like this, all, and it will be used as like all the data set will be used for training and validation. And if you want to do that, you can do it, but you need to make sure that the metrics that will be shown by the model in the validation process is not the best one, because the data that has been used for validation is the same one that has been used for training. So in this case, if you do want to use all of them, no issue. You can put all, so that you use most of your training data sets for the training. And then since you have already two other folders, the valid and the test sets, then you can use one of them for the validation. But this will be in reality, it will be testing, not validation, because it is not being used during the training. So it will be used after the training. So it is just kind of evaluation. So it depends to you if you want to use some of your training data sets for the validation, or if you want to use all of them. Because if we select 0, which means we take 1/5 of the data set, this means that this 1/5 data set will be isolated. So it will not be used for training, but will be used only for validation. But if you use all, then this means all of them will be used for training and validation. Okay. Then the next argument, which is the trainer. So the trainer, and then they have already some predefined trainers. I will show you here in their documentation. They have the trainer with the epochs. So they define the epochs. So you have 5 epochs. We have 1 epoch, and we have the 10 epochs. We have the 20, 50, 100, 250. This is the one that we are using. Then we have the 2000 epochs, 4000, and 8000. I, I I cannot say that this is stupid, but I don't like the way they are putting it like this. It could be very good if they leave it to us to define how many epochs do we want to use for the training, so that it could be just in the argument we change the number of epochs, it will be easier and more accurate. So for example, if I want to train my model on 300 epochs, we just need to put 300. But with the way they are putting it, you cannot just choose any number that you want. If you want to specify the number of epochs, let's say you want to train on 1000, which is not available here, so you need to copy, for example, this class, and then paste it and change to 1000, and you choose here 1000. So you need to create your own trainer, and then it will be used for your model. But as you can see, you will change the training code from nnUnet's repository, not repository, but the cloned repository that you have, and then you run the training, which is not the best way, as I may say, to do this. But yeah, if you are not comfortable with one of the trainers that we have here, then you can create your own and then use it for your training. Okay. Yeah, but apart from that, I don't see that there is something else that we need to discuss. We just need to run it here. So we have the training number, the dataset ID, configuration name, then the fold, and then the trainer. So if you have everything in your hand, which means after pre-process, you can just use this command. So I will go here and paste it. Okay, I'm always using no hub, so that now I will leave it no hub, so that we don't need to wait until the training completes. We just need to run it, and then at the end of the training I will just show you what has been done. And yeah, after this step you will just have your model where you can evaluate it, you can do the anything you want. But yeah, I will show you just one example after the training completes. I'll show you one example how you can use the trained model for the prediction and for the evaluation. Okay, so let's run the training and let's come back whenever the training is done. Yes, so just one more thing that I wanted to let you know, since the training is still running. So if you did use the no hub to do your training, or maybe if you didn't, and you may lose your terminal. So there are two ways: either tracking your outputs in the no hub that's out, but sometimes this file is not up to date. Maybe there are a lot of updates in the training, but you cannot see them. But if you want to see the real time updates, so you need to go to datasets where we are storing data, then to nnunet data where we have the nnunet results, and here you can track everything. Now you have your dataset, which is this one, the name of your dataset, and then the configuration, which is nnunet trainer 250 epochs, then the 3D full res. Okay, then we go here, and here you will find these are the configs that we will need later. But now you can go to this folder and you can track your training in this log. So this log file contains the logs, the real-time logs that are happening. So if you miss anything in the no hub that's out, you can come to this file and find everything about your training. So as you can see, it is starting the training, it reloaded the configuration, and now it is starting the training. So this is the first step. But as I said, if you are in a server or something, you need to close it in each time and reopen it to see the updates. But yeah, as you can see, there is a first checkpoint that has been done, and you can also check this image or screenshot that will be created in each epoch that contains the progress, which contains the validation and the training dice score. So I will just reopen this again and can see here, since it is the first epoch, then we don't see anything for the moment, but let's wait after a few epochs. But yeah, here if I reopen it again, as you can see, this is the first dice is 000. I remember when I did this training at the beginning, it will start just like this 0000. I don't know why, but just after a few epochs, about 10, 20 epochs, it will start increasing. So don't worry about that. Just leave it until the 100 epochs. If you see that you are in 100 epochs, but it is not showing anything, then you need to check your training. Maybe you missed something. But yeah, this is just what I wanted to mention. If you want to track your training in real time, you can check this file and also this image that contains the progress. So yeah, let's come back later when the training is done and see what are the next steps. Now, as we have the training that has been completed, so I just opened the training logs, the one that I told you about. So if you go here at the end, you see that the whole training is done, and also the validation process is done. And here we have the validation dice, which is 88.9%, which is a very, very good dice score for this kind of segmentation models, especially when you have multi-class. So I can say that is a good dice score. And if we go to see the training dice score, I think it is above 90. So let me just see. Yeah, it is about 91%. So the dice score for the training is about 91%, which is a good one. Yeah, 99.44. Yes, it is very good. And then for the validation, we have 88.96. Okay, so yeah, this is the training log. If you go to this folder, as you remember, we have the results. Then here the folder of our data sets. Then if we go here to the trainer of 250, so it depends to the trainer that you use. If you are using another one, maybe a custom one, so you will find a folder with the name of your trainer, and then you will have this file that will be used, especially the plan and dataset. You will need them also for the inference later. And also here we have the training log. We have the progress image that shows the progress during the training. Let's just open it and see what it gives. Okay, just 1 second. Okay, so let me just move it here. Okay, so as you can see, it is above 80%. Like it is also above 90%, which is a good dice score. So this is for the training, and also we have for the validation, we have the loss validation and the training validation, and as you can see, they are almost the same, which means we don't have the overfitting in this model. And then in the same folder here we have the model checkpoints. This is the best one, so whenever we have the validation we should have the best one, and this one is the final. And since the final epoch generated the best model, so both of them has the same weights until sometime, because sometimes maybe you will have the best model in the validation data that has been generated or trained maybe let's say 10 or 20 epochs before the end of the training. So that model or those checkpoints are the one which will be saved as best, and the final one is like the final epoch, like the model that will be saved after the final epoch. And since for us the final epoch was also generating the best weights, so both of them are the same. Okay, and here we have the validation folder that contains the validation output. So if you want to visualize them or something, you can just download this folder and visualize your data set that has been used for validation. Okay, so now after completing this, what we have to do now, we can, if you want, I will just add this process for you. So if any one of you wants to do that, which is how to evaluate your model, which means we can have a folder of data sets, we do the prediction, and then we do the evaluation of the predictions. But before that, if you remember when we did the split of the data set here in the nnUNet row, in data set 100 spine, as you remember, we have the training, image training, and we have label training, and then we have the image testing. So this folder, it contains the image and the labels for testing. So in previous versions of nnUNet, we could do the prediction and the evaluation in this structure, and there was no issue, as the nnUNet can detect that these are scans and these are labels. But I think for this new versions, it is not working like that. So preferably to avoid any issue, what we will do, we'll create another folder which will be labels ts for the testing, and there we will put the labels, so that we can have two separate folders, one for the scans and one for the labels, so that we can avoid any issue with this version of nnUNet or any other version. Okay, so let's just create a new folder. Let's call it, for example, labels ts. This is just a convention. It is not necessary to call it like this. Here I'm talking about the label testing, so we don't care about this, like for either the image testing or the label testing, so we can call them whatever we want. The most important ones are the training images and the training labels. Okay, and as just to mention, the training image, the testing images hasn't been used till now. like neither for training nor for the validation. So these are really images or scans that hasn't been used or seen by the model. So if we get good results or good matrices by these scans, this means that the model is working well for this kind of tasks. Okay, so what we will do, we'll just copy the segmentations from the testing folder and put them in the labels. So just to sort them, I would just sort them by file size, which will be easier to find all the segmentations. And then I will just copy till here, and then let's cut them and label testing, and then let's paste them here. Okay, let's just wait for 3 4 seconds to complete the cutting. So okay. Okay, so now we have the testing labels and we have the testing images in two separate folders. Okay, so what we can do now, we can do the prediction, which means we will predict the segmentation or the prediction mask of all the testing images. And then whenever we complete that, what we will do, we'll run the evaluation script that will evaluate the model comparing the ground truth, which are the label testing, and the predictions. So I just want to create another folder here. I will call it nnUnet predictions, so that we can use it for to store our predictions. So it is. I will just call it like this. It is just my choice. You don't really need to call it like this. It depends to what you want, because at the end we'll just give the path to this folder. So whatever you will call it, it doesn't matter. Okay, so I will just create it here. Now we have everything done. What we can, let me just close this, and also this, we don't need this anymore. What we'll do, we'll use the commands that we discussed. Let me just take this. We'll just use the command that we discussed at the beginning of the course. If you remember, we have these last two commands. So this one is for the prediction, so it will predict all the masks of a folder that we will give, and this one will do the evaluation of the folder. Okay, so let's start with this command. I will just copy it and paste it in the terminal, and then I will explain what are the different arguments. Okay, so here we have the first argument, or the first part of the command, which is nnUNetv2 predict. So here we are running the prediction, then minus e or dash e, which means we will give the path to the input folder. And since for us we have this dataset 100 spine, then image ts for the testing. So this is our input folder. Then for the output, where we want to save the predictions, so we have the workspace dataset and unit data. Then we have I think the path is not complete, but the path here is the same one that we created at the beginning, which is nnUnet predictions. So I think we just cannot see the whole path here, but just I will just show you in the Notion here. So the output path, which is the workspace datasets, nnUnet data, then the nnUnet predictions, the folder that we just created. Okay, so for this design, I told you can call it whatever you want, because at the end you will just give the path. Okay, and then after having the path to the predictions, we need to specify what is the ID of the dataset, which is 100. Then I will just let you know why we are doing this, because nnUnet, they built their model that will search for your inputs, outputs, arguments, everything. It will search for it kind of automatically, but I don't like that way. So I will just let you know why they put this. So we have the 100, which is the ID of datasets, and we need to specify which trainer, which configuration we use, which is 3D full res, then which trainer, and then here I think I missed something. So for the fold, it is not all, but it is 0. Okay, so now I will show you where we will use these. Actually, the idea of using of giving those specific parameters, which are the first thing that we gave, which is the 100. So we gave 100 for that, so that nnUnet will go. The first thing that we'll do, will go to the nnUnet results. Then it will try to find what is the dataset that has the ID 100. So if you have multiple datasets, then it will select only the one that you gave, which is 100. So this is what will happen. now, which is giving the data, the ID of data, which is 100. So that you will select this folder. So this is one. Then you have the second parameter, which is the 3D full res. So why we are using this? Because we need the 3D full res and we need the trainer. So here we are saying the 3D full res and we are saying the trainer is 250 epochs. Why? Because the folder that is storing the results now is called the nnunet trainer 250 epochs, then the nnunet trainer plan, then 3D full res. So if you maybe why they are doing this, so if maybe for you you want to do the training several times with different configs, so for example you do training for 250 epochs and you do another training for 2000 epochs, so in that case you will have two folders, one with 250 epochs and another one with 2000. So in this case, you will have two separate folders, and each folder contains different the configurations, which are the model weights, etc., etc. So in that case, you need to select which one you want to use for the inference. So to select that, you are giving just the parameters, which are the nnunet 250 epochs and the 3D full res. So that nnunet will look for a folder that has the 3D full res and the nnunet trainer. I know that this is not the best way how to define that, but they are putting it like this. We need to respect it. For me, as myself, whenever I work with any unit for my projects, I don't leave it like this, but I customize it. So I do some changes in the nnUNet code so that I don't need to give all these arguments to specify where the model can find the model weight and the plan.json and the dataset.json. I just need to give the one part to one folder that contains everything, which is the logic how we do everything for our products or our projects. For that case, I needed to change the nnUNet itself in the inference code. So for you, if this doesn't bother you, then you can leave it like this, but you need to specify whenever you use the prediction or inference or something like this. For using an nnunet, you need to use these and specify them. Otherwise, you can change them, as I said. And it will be very easy to do that. It's not a problem. You just need to delete some subfolders and make the whole folder as the whole pointer. So you just give one folder, it will contain everything, and they will not care about that. Okay, but you need to change it. And then the other thing, which is the fold, which is like either 0, 1, 2, 3, 4, or all, which we discussed before, which is what is the validation sets that we wanted to use, either the first portion, second portion, or all the portions. So for us, since we used 0, then I will put 0. Also, why we need to specify that, because whenever we go to this folder, maybe you did several trainings, maybe you did trainings with the 0 and with the 1, with the 2, with the 3. So in that case, you will have different folders here, and each folder contains like a different arguments. And for us, since we have for us we have only one, but if you have multiple ones, then you need to select only one. But since we have only one, then we have the 0. So we need to specify the 0 so that any unit can find the folder fold 0. And at the same thing, any unit will use the dataset and the plan, and also whenever we go here we have the checkpoints, so it will take the checkpoints and use them for the training, for the prediction, sorry. So yeah, as I said, this is all what we have to do. Everything is set, everything is ready. What we need to do now, we can just run the command. I will run it here. So this can take some time to do the prediction on. We have here, as you can see, 217 cases, which is not something that will be run in 1 minute. So as you can see, the prediction is not taking long time, but since we have a lot of cases, then it will take a long time. So what we can do, I will just stop the video until completing everything, and then we can run the evaluation. Well, so now we are at the end of the prediction. So we have everything, like all the cases has been predicted. Now we can do the evaluation on of the folder. So this will be the last part of the course. So yeah, I hope that everything was working well, and I hope that you had some information of how to use an unit for your MS segmentation models. As I said at the beginning of the course, I didn't have much things to prepare, so maybe we had some errors, some issues during the course, but this was, I cannot say that it was part of the process, but at least we face some issues that we can solve together. And I hope that if you follow the same steps that I shown here, you will not find issues with your trainings. And yeah, so let's do the final part of the course, and let's see what it gives. So here, as I said, this is the latest part of the course. So this is the command that we'll use to evaluate the folder. So this command takes some parameters as well. The first parameter that we'll take, which is the ground truth, which is where we have the labels. So for us, it will be the labels TS, which is the testing labels. Then it will take the predictions, which are saved in the nnUNet predictions. Then it will take the D the dataset JSON file. So the dataset JSON file is the file that we have created or uploaded that contains the information about the dataset. So we can find it just here, here, and then in the row. Okay, predictions. I think we have two folders here, maybe because we have missed something in the name. Yes. So I think this one, yeah, this one contains the file. So yeah, we just need to delete this one so that we don't get confused. So we just needed the upper end. So in the command we used upper end, but in the when we created the folder it was lowercase n. Okay, but that's an issue. Okay, now we can go to the data and a new net row and the dataset 100 spine. And if you go here, you will find the dataset JSON file. So this file is located in like 3 or 4 locations, but this one is the base one. This is what the file that we have created at the beginning. So you can just copy the part of this file and put it here for the dataset JSON file parameter or argument, and you give it. And then we have the P file, which is the plan file. So the plan file is also located in several parts. The most known location is in the results, and then we go in the dataset, then in the trainer, and you have this plans.json. So this is the file that we need also as an argument. You just need to copy the path to this file, and then you use it directly here in the -p file, which is the plan file. And yes, that's it. These are the parameters that we need, which are the plan file, the dataset.json file, the predictions, and also the ground truth, which are the labels. Okay, so I will just copy the command, and now we can use it in our so let me just copy this, and now we can use it directly here. So I will clean it, clear, and then let's use the same command. Okay, let's run it. It will not take a long time, but I will stop the video so that even if it takes 1 or 2 minutes, we'll not just wait for 1 minute. So whenever it is done, I will resume the video. So now we have the whole evaluation of the folder has been completed. It didn't take more than 3 minutes. So yeah, we have everything there. Now, as you can see, we don't have anything in the terminal. But if we go to the predictions folder here, predictions, okay, we will find a file called summary, which is, let me just move this, which is this file. I cannot open it here in the server, so I will just download it and open it in my local. Okay, so that we can see what we have in this file. So okay, let me just take it here. So as you can see, there are different parts in this file. The first part, which is the mean or the average, which let's say the average of the precisions or of the metrics in general. So as you can see, for the dice score, we have 0.85% for all of them, and for the false negative, false positive, intersection over the union, as you can see, it is 81. Okay, now we have the true negative, true positive, then number of predictions, number of references. But these I don't use them usually. So the most important ones that I use, like either intersection over union or dice, because like both of them has almost the same equation. So, and the most used one is the dice score. So if you prefer the others, you can take them. But if you just need one metric, so I think the dice score is enough for you to present it. And yeah, if you want to do more, then for sure you can calculate other matrices, but you need to create your scripts by yourself and not use this the nnunet one. But yes, this is for all the cases. This is the average. Then here we have the precision per class, but for all the cases. So for all the cases per class, we have these. So the class 1, class 10, class 11, etc., etc. And then you have the dice, like the same matrices here. We have the dice for negative, for positive, etc., etc. Then these, as I said, these are per classes. So each class you can see which class is weak, which class is doing well, because you can see that sometimes some classes are about 90%, others about 70. So you can just check which class is not doing well. Maybe you can increase more data sets. Maybe you can verify if that class is segmented well or not. So it depends to the specific dataset. But as you can see, there is no big difference. Only sometimes, as you can see here, it is about 67% compared to the others, which are most of them are above 80. But of course, if you see something like this, you may go and check this specific class. Maybe there are some issues with the annotation or something. But yeah, this is something that you need to consider if you want to increase the accuracy of your model. And then we have here the matrices per case. So the first case, second case, etc., etc. So you can see for each case which are the different matrices. So for example, this case, as you can see, it is about 95% for the dice, which is a good let's say good score as dice score. But compared to others, maybe others are 60 or 50 or 70, depends to the case and the difficulty of that case. But yes, this is what you will get when you do the evaluation, and you can use these matrices to evaluate your model to compare it with other state of the art models or something like this. And yeah, I think now we are at the end of the video. We will have just the latest, the last section, let's say, which will be something kind of a demo where we can use the models that we have used and trained in this course. And these models will be you will be used to show you, just like it will be small demo where we show you where you can use your okay, let me just close this. It will be just a small demo that will show you where you can deploy your models, but like we will not deploy the models in real time. I will just show small videos where we use the models. So it can be kind of Tkinter application, or it can be kind of Streamlit application or something like this. So it will be just kind of ideas so that you can think of how you use it. If maybe you are using, if you already have your production pipeline, then you don't need this part. But otherwise, if you are still looking where you can go with this final model, then I will give you just some ideas that can help you with that. So yeah, thank you for your assistance. I hope that the course was helpful for of you, or maybe some of you. And if you have any questions, or if you like the video, don't forget to thumbs up or leave a comment about that. And for sure, we can see you with other courses and other videos. So see you. Bye bye.